Hello, everyone, and welcome. I believe it is day 25 of Handmade Hero. We have come to the end of a long journey, building our Win32 platform layer. And I know it seems like a long time because it's been 25 days, but each day is only an hour of code that we get to do, really. So if you think about it, if we started on Monday, and it was, we were working standard, 8-hour day with an hour for lunch or something like this. So we were working 7 hours a day. We're talking about less than 4 days. So if we started on a Monday at work, we would have been done with this by Thursday. That's how little actual coding work we've done. It's because at only an hour a night, it just doesn't add up to very much. So I know it seems like we've spent a long time here, but really, this is not very much. And that's with all the explanations and everything. So building a Win32 prototyping layer is really not that hard. Building a shippable Win32 layer, which we'll have to address later on, definitely takes more work. Like there's stuff that we have not done because we're just trying to build something that we can prototype on. So there will be more Win32 work involved down the road when we get to that point. But even then, it's not going to be a huge amount of work. It's not going to take us years, right? It's going to be something fairly straightforward. So I think it's important to just kind of take a moment and go, gosh, there really isn't that much work to do here. We haven't even done a week's worth of programming work yet. And we already have a prototyping layer that's got a bunch of features in it and works pretty well for our purposes. And there's some stuff that we didn't do because we're not using hardware acceleration yet, but adding hardware acceleration is actually pretty simple, you'll see. And so at that point, you kind of have something that's pretty close to a shipping layer. So I don't know. I think we're in pretty good shape, and it really didn't take us that long. So that said, today is going to be the last day of Win32 specific coding. Basically what we're going to do today is just finish the cleanup that we started yesterday and maybe do a little bit of recap. But for the most part, after today, we will no longer be thinking of Win32 programming. The only time we'll go back to Win32 handmade.cpp is when we sort of want to hoist things out of it now. Because as we start building the platform independent part of things, some of the stuff that we did in the Win32 layer will no longer be necessary to do in the Win32 layer, and we'll kind of pull those things out. And also there's a bunch of like to-dos in the Win32 handmade.cpp that are things that we can't do now because we don't have services like logging. But when we build those services in the platform independent layer, we can go back into Win32 handmade, and all those to-dos we can just put log calls in there and they'll call up to the platform independent layer. So for the most part, we will be leaving Win32 handmade.cpp behind, but we will still bounce back and forth to it as necessary to kind of pull services up from there into the platform independent portion. So let's go ahead and if you have pre-ordered the source code using handmadehero.org's handy dandy pre-order button, you should have gotten a link in your email. That link contains a zip file which has tons of zips in it. Each one corresponds to a day. We are on day 25, so you want to unzip day 24's source code. That is what I am working with right now, and that is what you will be working with as well if you are following along at home. So let's go ahead and bring up the Handmade Hero source code here. I never remember what the source tree looks like somehow. But I have some notes, which I'm going to take a look at here, just to see what else it was that I wanted to do. Okay. Sorry about that. This headset is causing me problems today. Never have wet ears when you're going to do a headphones-oriented broadcast. Okay. So it looks to me like there's not very much left to do. There's just a couple little things. So I think what we'll probably do is try to do those couple little things, and then I might go ahead and do the work of speeding up our replay stuff, because I talked about some ways we could make that faster, especially on a machine that doesn't have an SD drive, which this one doesn't. And so maybe we'll play around with some things to see if we can't make that faster, because it's a little slow right now on the record. So, all right, so the first thing that we want to do is let's just go ahead for the sake of completeness. We do think, we talked about this a little bit on the forums, and it does seem like for most platforms, from what people could determine, we could actually do a fairly cheap call here and most of the time get the monitor refresh rate. That's what people think anyway. We're not sure, so when it comes time to ship this stuff, we're going to have to do certainly a more thorough job of like testing it on a number of platforms to see if we're getting a reasonable one. But when it comes to shipping too, we'll probably use a different service for syncing with the vertical retrace anyway, like you know, OpenGL or Direct3D will actually be doing that sync for us, so we may not even have to care at that point. But I believe monitor refresh rate queries, we can actually use the one that we avoided using. Excuse me. I believe it's these are not. This is not it. It's the get system. It's like get system metrics, something like this, call that we can just call, and it assuming that it doesn't encounter one of the conditions where it doesn't know the monitor refresh rate, apparently it will actually return an OK monitor refresh rate, I believe. I'm not sure if it's actually, I think, you know what, it's like get device caps, I think was the one we were looking at. We looked at it already. I was just like, it doesn't look like it's going to always return it, so I was shying away from it, but apparently it'll be fine. Yeah, so this is it. So it's basically get device caps with this V refresh thing. And this was the part I was scared about. But apparently, most of the time, this actually does work. So since right now we're hard coding it, it's probably better than nothing to go ahead and actually do something real here. So we could basically say that there's a monitor refresh hertz. We'll assume it's 60, which is what we were already doing. But then what we can do is go ahead and call this get device caps on the actual excuse me, on the actual HDC of our window, and in theory, that will at least sometimes, assuming we can, you know, actually rely on it at all, at least give us a better monitor refresh in case the monitor refresh or something else in Windows actually did know. So basically what we'll do here is we'll say, all right, we're going to get an int back, which is the vrefresh Win32 refresh rate. We'll see what that is. If Win32 refresh rate is greater than 1, basically, because we know we might get a 0 or a 1. It's documented as possibly saying that. If it's greater than 0 or 1, we'll assume that it actually is giving us a valid value. Now, whether this is, how reliable this is, we don't know. This is definitely something we would have to, you know, have to spend more time investigating if we wanted to ship this directly. But for our, again, for our prototyping purposes, we should be okay. And so, from there, we should be able to define the game update hertz. Let's go ahead and, let's see, do we have, where do we actually use game update hertz? Where is that used? Looks like that is used. So the game updates hertz, we're kind of relying on that to be a round number. I don't know how good of an idea that actually is, because if it can't be divisible by 2, almost all the monitor refresh rates are going to be divisible by 2. So I don't know how much we really care about that. But you notice, like, if we're storing this in integer here, then if this was going to be fractional, then we'd be in a problem. Like, let's say this was 59 hertz, right? That would be kind of nasty because we're not getting the right result here for target seconds per frame. So that doesn't fill me with joy. I don't love that. So I'm wondering if maybe we can just go ahead and do something a little saner here. Let's see what we've got. So latency sample count, that isn't used anymore. So we can just ice that, I believe, latency sample count entirely, right? At least I think so. And yeah. So game update hertz, we can fix that guy right there as well. So game update hertz is really only used here in safety bytes. So in safety bytes, it looks like, I mean, we could just use an actual real 32 there and just do the math and then cast down, right? I mean, we can certainly do something like this, right, where we're actually just doing the math at floating point, and then at the very end, we cast it back to some kind of an integer. So I feel like that's probably fine. And then we know that at least we'll handle fractional values okay. So I'm basically going to say, all right, let's just do it that way, right? What's interesting is you'll notice game update hertz is always used inverted, right? It's always divided by game update hertz. So it's almost like we probably shouldn't have bothered. We probably should do it inverted already, right? And just multiply by it, since it's always used that way, and, you know, whatever. But yeah, that's not the kind of thing you actually need to worry about, but it just kind of caught my eye. All right, so anyway, we need our HDC here, so we need to do our get DC of the window, and then we can. So we're gonna query this for the refresh, and hopefully this will work. We don't know. We're gonna at least step in and make sure it at least works on our machine, right? Because we don't even know that yet. So I'm gonna go ahead and just go ahead and do that here. In fact, I guess we can just full on bracket that. call directly, and then all we need to do is clean up anything where this was not going to, yeah, okay, so we can, where this was not going to work with our change of that to a real. What did I do? Okay, I've got to convert this guy to an integer. So once we do all this math in floating point, then we can convert it to an integer, and that'll be fine. I'd like to format this a little bit better. Let's see. And then, so the only thing we have to deal with is this guy. We don't really care about this. I don't know why I even made it based on game update hertz. We just need some number of debug time markers. So basically, we could just say that there are 30 debug time markers or something, right? I mean, we don't really even care how many there are. The last 20 are kept or something like that is fine. So that should probably be fine. And I'm going to just take a look and see and make sure that all that was kosher. So at least we're still working okay. I want to go ahead and take a look at what that call looks like, where we get the vertical refresh. Let's go in here. There we go. So let's see, we get the refresh DC back. We take a look at the refresh rate. It does return 60. We release it. We go ahead and set that. Modify refresh rate. Okay, game update hertz is 30, which is what we wanted, and everything looks kosher. Okay, so that's fine. No big deal there, but that seems fine. So that's good. I would say, taking a look here, so I'm going to cross that off of our list. So we got that. That looks good. All this looks good. So I'm going to introduce a little concept here that I want to do, which is, I realize it may be a little confusing and it probably won't make very much sense until we get a little further into things. But I just want to introduce a concept here that will save us some time. And it's kind of the way I like to do things. It'll save us some time. It's sort of one of those, in my experience, it is a good idea to have one of these things and have it early so that you don't have to sort of add it into your code later. It's sort of a having learned by doing kind of a situation. When you are porting, you find that you tend to need these things. On Win32, you actually don't really need the thing I'm about to do typically that much. Because there's ways you can get around it, but on other platforms there aren't always. So what I'm going to do is, in the platform non-specific layer, I'm going to introduce something, and you'll just have to take my word for it because you won't actually see why this is necessary for a little while. I'll just have to kind of tell you why. I'm going to kind of tell you now why it's a good thing to do, and you're just going to have to take my word for it. But basically what I want to do is introduce something called a thread context, right? And what a thread context is it's just a handle or an informational structure that's passed along through every execution chain in the game. So basically, whenever I call something in the game, like we've got 2 functions in the game, and that may be all that we'll ever have. But whenever I call something in the game, the platform layer will pass this thread context. It'll just pass that into whatever it calls. And for right now, the thread context will have absolutely nothing in it, right? Because we have no idea what that's even going to be used for. Like I said, it's something that you're just going to take my word for. But basically what will happen is any time that you actually use some kind of operating system service, you're going to need to use one of these thread contexts. So basically what I want to do is say, all right, if you ever call back into the platform layer at all, you're going to have to use one of these thread contexts. And the thread context is essentially like something, that's going to get passed into these, for example. So whenever you ask to free file memory or any of this stuff, you always have to pass your thread context. And essentially, all this is it makes up for the fact that not every platform does a good job of giving you information that you can use about what thread you're in when you're running multi-threaded. Since we haven't covered multi-threaded, like I said, it's a little bit difficult for me to explain why this actually matters. But I'll try to do a little bit of that in a second here. So, all right, let's go ahead and get that compiling. And then in here, let's see here, go ahead and get that in there. What did I do? Debug platform read entire file. Did I not call it thread? I called it context. Fantastic. Nothing like starting the day off with inconsistent naming. Always a good thing. You could tell how absent-minded I am when I'm trying to talk and stream at the same time. It is often hard for me to focus on the code that I'm writing. It makes it kind of difficult, to be honest with you. All right, so what we need to do is pass that thread context here. Again, nothing is actually happening with it, but we need to pass it. And so what I'm going to do is just create a dummy thread handle. Basically, it's just going to be thread context like this, and it's going to have absolutely nothing in it, nothing important whatsoever. Again, did it again. Really want to call that context for some reason. And then these guys just get that empty handle. All right, and so what I want to do here is I want to introduce this concept just because the thread context is, it's basically, there's a lot of things that happen when you go start doing multi-threaded code where you want to know which thread is which. So you'll be inside some code and you'll be doing something and you're like, this could be made a lot more efficient if I had, say, one buffer per thread that each of these threads could write into. But unfortunately, I'm in the middle of this code and I don't know what buffer goes with the thread that I'm in, right? So there's just these kinds of situations that you get into when you're in the middle of coding stuff that's multi-threaded, where you really want one thing per thread, or you want to know which thread you're in for some reason and have one thing inside your own code per thread, that sort of stuff. And so typically you want to be able to define like thread indexes and have pointers to thread specific things. In Windows, if you're not in a DLL, or well, I shouldn't say if you're not in a DLL. In Windows, most of the time, you can get what's called thread local storage, which will sort of do this process for you so that you don't need that thread context handle. But there are other platforms where that's not true, and depending on the circumstances, you may not really want to do it in Windows either, and blah, blah, blah. So really, I'm just setting this up sort of as a predictive thing where I just want to get in the habit of having the game code always know sort of a thread handle for itself that it can use. And it does take a little bit of overhead to do this because it does have to get passed around. But on the whole, I find that it's just easier to do that than to deal with the alternatives. So that's the way I'm going to choose to do it in this particular case. I'm just introducing this now. So that's it. We don't have to do anything with it now. I just want to get used to that and get used to kind of having that get passed through, because I would like to be able to use that for a bunch of different things. So that's all there is for that. And the other thing that I wanted to do, again, just miscellaneous cleanup, is one thing that I did notice is we don't pass any mouse input to the game. And we don't need that for any particular reason because we won't really be supporting the mouse as a controller. Like, you'll be playing with the keyboard because it's kind of more of a digitally kind of game. So the mouse isn't really probably going to be appropriate. But what I would like to do, in case we want to develop some debug overlay systems that might be more appropriate for using with the mouse, or if we want to use the mouse to like move elements in some kind of an editing mode or anything like that, what I would like to do is essentially introduce here just some mouse debug stuff, right? So, you know, something like, you know, a mouse buttons flag and a mouse X, mouse Y sort of a situation. Just something like that where we can sort of pass the mouse information to the game. And it can be super janky and awful. It doesn't even matter because it's only going to be used for our debugging purposes. But, you know, I just kind of would like to have something like that in there. And maybe we'll use the half transition count thing. I don't know if that's a good idea. Maybe we'll use the half transition count thing for that since everything else uses it. So maybe we'll do something like this where we do mouse buttons. And we say, okay, you know, how many mouse buttons are there on this thing? I think there's 5 on this thing. I don't know if mouse button have so many, mice have so many buttons these days. And then of course we've got a mouse Z, I suppose, as well, which is that little mouse wheel thing. And so I just want to create that state there, have it so that the game can get it. And also let's go ahead and just drop in, you know, something where we can see if we're actually passing that correctly, and then I'll pass it correctly in Win32. So we have that little, we have the render player thing, right? We have a render player call. Let's get that up above my head. And so maybe we'll just go ahead and say, let's render where we're getting told the mouse is, right? So we have a mouse X in the input layer, and we have a mouse Y in the input layer. So let's just go ahead and do that so that we can see that we have that mouse cursor position. And then I will go in, that should compile now, I think. Yeah. I will go in and just add the minimum necessary nonsense to get the mouse out. So basically in here, if we only care about where the mouse is right before we call it, really, okay, so when we process our like X input stuff, we do our controller input stuff, we can do it right here. We have that new input pointer, right? We have new input, and we just want to go ahead and set these values, all these values here. So that'd be mouse X, new input mouse Y, new input mouse Z. I don't know if we can get in the way that I'm about to do the other ones, but if we don't support mouse wheel right now, I don't really care. That doesn't actually matter to me very much. And then we'll at least track those 3 buttons as well there, or buttons as I occasionally say them. Nice spelling there, Casey. So what we can do if we just want to, if all we need is just some mouse information, there's actually a get cursor pause function in Windows that will basically tell you where the mouse is at any given time. It's pretty trivial to use, right? Basically what you do is you call this, and the main cursor, whatever the main mouse is on the system, wherever this little thing is that I'm wiggling around right now, when you call that, you can just get wherever it thinks that thing is. So basically, we can say this is the mouse location. We can get that, and then we don't even care if this thing fails or not. It literally does not matter to us because this is strictly debug information. So we can then take a look at this point structure that comes back, and it gives us this long X and Y. Now the problem is if we use this directly, well, you know what? Let me show you what happens if we use it directly, so that you'll understand exactly what I mean. So I won't have to give this explanation blind. You can actually see what actually happens. So if I go ahead and run this, you'll note that we are getting that mouse. You can see that we're getting that mouse position, but you'll notice that it's wrong, right? You see how that's kind of wrong? So what's going on there, right? Well, what's going on is when we call that get cursor position function, it gives us back the cursor position on the screen. But our window, our coordinate system actually that we're drawing on, I know we haven't covered coordinate systems much yet. We're going to talk about that a lot when we get to the renderer. But if you think about it, if we say the point 0, 0, we're talking about this point right here. But on the screen, 0, 0 is up there. So you can see it lines up exactly, where if I move the mouse all the way to the top like that, now we're in the upper corner. So what we need to do is we need to find a way to sort of map that cursor position into our Windows coordinate system, because this is in the wrong coordinate system. And coordinate systems, like I said, we'll talk about a lot. So if you don't know what those are and you're a little lost right now, it's totally okay, just ignore it. We are going to talk about this a lot later on when we start implementing our coordinate system stuff. So you will have plenty of chance to kind of understand that. And this is not an important part of the code that we're writing right now, so you can literally ignore this entirely if you want to. I believe there is something called screen to client, if I remember the name correctly. Screen to client will basically do that mapping, the exact mapping that we want. You pass it a window and you give it the point, and it just maps it from the screen into your client rect space. Now you remember we did that get client rect thing that basically says what our window rectangle is. Well, it's literally that mapping. It maps it into that rectangle, which is exactly what we want. Right? So we can just say, hey, get the screen to client for this window that we've got and map it for us, please. Right? Oops. Missing a slash there all of a sudden. So that will correct it, and now you notice that it is right on target. Now remember, we're drawing our rectangle as if the upper left corner is the position, so that's why it's there. You know, if we were actually doing a mouse cursor, we might want to do an arrow, or we might want to like center the rectangle over it or something like that. But for now, we can tell that we're getting the input properly. So really all we need to know now is we need to know whether or not we had a mouse button up or down. So the way we could do that, if we wanted to, is we can sort of do that in line with that, with when we sort of do all that keyboard processing, you know, this sort of stuff. So what we could do there is we could say, all right, let's go ahead and process mouse up, mouse down messages here, right? We could, I think we also could get them. We might be able to just kind of. I'm so torn. I'm so torn. It depends on how robust we actually want our mouse processing to be. Since it's just debug, I'm tempted to not even bother, and maybe just see if we're fine. Basically, I'm tempted here, ladies and gentlemen. What I am tempted to do, I will tell you, I am tempted to just go ahead and just query it straight away, right in here, and just see. Oh, it's. All right, I think I'm going to do that. So I believe this is crazy. You know, don't ask me why I know all this stuff. It's just you wish that your brain didn't even have this information in it because it's just so ridiculous that I even know this stuff. So basically, there's a function that gets the state of the keyboard for you. And it's the state of the keyboard as of your last message that you pulled off of the message queue, because Windows tracks that for you. And so you may be asking, why would that matter at all? Why would we want to do a get key state call? And you can see that it returns the high order bit is set if the key is down, that the high order bit is not set, then it's not down. And it's a short, so it's 16 bits. So basically, we could use this to see whether keys are up or down. And you may be saying, why would you care about that, Casey? Because we are not looking at the keyboard, we are looking at the mouse. Well, if I remember correctly, and sadly, I think I do remember correctly, you can actually ask for the mouse cursor VK code. So basically, if we do something like look at the VK code table, which I assume I can just look at here, virtual key codes, and just typing any VK in there. Oh, there it is, right? This is exactly what I'm talking about. You see those? VKL button, VKM button. You can ask for those as if you were asking for a key. So I can literally go through here and ask for the R button, the M button, and these X buttons, which are those extended buttons, X button 1, X button 2. I can ask for those as if I'm asking for keys. I can ask for them at any time, and it will tell me whether or not they're down. So, you know, let's just do that. Let's just go ahead and do that. I don't actually remember. We think we have a utility call here that'll do this sort of weird stuff for us that we needed to do for our cycle counts. So where was that guy? It was Win32 process keyboard message. This is actually, I think, all we really need, right? Because we're sort of treating this right just like a keyboard message. So I can just call this, and it'll do exactly what we want, right? We can just, oops, that's great. We can just do this, I think, and then use that this get key state for whatever the button is, and it with that top value. And I believe they said that it was a short, right? So the high bit is going to be 1 shifted up by 15, if I understand the documentation correctly. So that's like all we really need to do, I think. Let's find out. Let's find out. L button, M button, R button, X button 1, and X button 2 will be in there. That'll be lovely, I suppose. And I think in theory, that is it. Let me see if that's true. New input mouse buttons is not a member of new input. Is that true? Are you lying to me? I doubt you are. You're a compiler. You don't often lie, although sometimes you do. You never know. So game input, mouse, oh, well, if you spell it wrong, there you go. All right, so I think that's literally all we need to do to process that. Yeah, I don't think there's really much else we'd have to do. And we've got a to-do here if we ever want to support mouse wheel, which, I don't know. We don't really have zooming in this game because it's a 2D game, so we probably don't really need the mouse wheel for anything, but if we found out we did, we would be sad because we're not supporting it. All right, so what we need now is just some way to see if those are working. Let's go ahead and, again, leverage our render player function here. When you can render, you'll see this. This is just how programming works, too. It's kind of cool. Soon we'll start to be having a lot of functions that we can reuse. We haven't really gotten to that point yet, but we're going to be there very shortly once we start building renderer tools and all these other tools. And it's kind of nice. Once you have one thing working, it builds on itself so quickly. Like before we had really no way to indicate anything, and now we can just call this one function that draws a rectangle. Excuse me. And we can essentially use that function to do all sorts of other stuff. So, right, for example, I can do something where I just say, all right, mouse buttons 0 ended down, right? I think that's what we have as our thing. I can just do that and see, I should see a rectangle happen. Ooh, what did I do? New state ended down is not equal to is down. Okay, so that's our assertion there. I guess I don't actually know if this will work then. Do we? Because we don't. Okay. We don't send this guy toggles. So this would still, yeah, So I wonder if I just want to make this function. You see what happened there? What happened was we were previously guaranteeing essentially that we always handed this guy is down, not is down, is down, not is down. We would never hand it like 2 is downs or 2 is ups in a row because we were processing incoming messages. I think what I'd rather do here, because I want to make this more robust so I can just throw it whatever this current state is and have it work, I think what I want to do is kind of just say, you know, if it's not equal, then do the processing. And that just will just work at that point, right? Because that way I can use it for more things, and I don't know, I feel like that's just going to be more what we're going to want. So I can throw stuff at it and it just works. So you see that up in the corner, do you see that guy there? That's showing us that the button is down and pushing the button up, down, up, down, up, down. So that's totally good. Let's go ahead and real quickly drop a 4. I'm going to drop a 4 on this, yo. Let's go ahead and whip out that for loop. Everyone knows how much we love a for loop. Button index, right? Because I wrote this once, no need to write it again. Just write it once and throw a loop in there, right? Let's go ahead and loop over all of the ones, right, that are in this array, this mouse buttons array. I can just say for everything in that array, however many there are, I'm going to do one for each of it. And then why not go ahead and add something, let's say 20 times the button index, to just move it over. So I'm basically going to move where I render over by 20 pixels every time we increment that button count, right? Off we go. There's our first 3 buttons, left, middle, right. There's our 2 X buttons on the side. There we go. Mouse input done. Completely finished. So that's always good. Can I hold them all down at once? Yeah, there we go. It's hard to do on my mouse. I don't have like, you know why? I don't have some kind of crazy gaming mouse. I need one of those mice where you put like weights in them so your mouse is like totally perfectly counterbalanced. That's the way you get the high scores, yo. Like, who uses a mouse without weights in it? It's ridiculous. Come on. I'm totally behind the times. All right, so that's all we really needed for mouse, mouse, however you want to say that. Debug mouse cursor, done. And I don't see anything else on this list, to be honest with you. So I think that's basically it. So, there we go. I'm going to go ahead and slam in the slightly potentially more optimal version of the replay code because I don't really know why just because some people were nervous about how long it took. And so we might as well spend a little bit of time, since it's not particularly difficult, basically using all of the crazy huge amount of system resources that we have now to speed it up. Because, I mean, hey, if you're going to have machines, you know, this machine, I don't even know how much physical memory this thing has. Let's see. So this thing has... So total, so I guess that's telling me we have 12 gigabytes of memory. Is that what we want to say there? Let's say that that's true. So if we have 12 gigabytes of memory, and we're only taking 1 gig, so yeah, so we can just abuse the physical memory in this machine. We can just, you know what? I think it's time. I was going to save this for the right time, but the right time may be now. I think it's time to get piggy. That's what I think. I think it's time to just like be a total pig and just use all the memory in this machine because it's there, right? So I don't see any reason why we shouldn't just go to town. It seems like if we've got the pig hat on, you know, nothing's going to stop us. So let's just go ahead and say, because we can, that what we're going to do here is we are going to create backing stores for all of this stuff, right? We're just going to go ahead and create backing stores for this game memory block. So we'll do that one way first, and then we'll do it in a slightly different way immediately thereafter. So what I'm going to do is I'm going to say that we have a particular count and of these Win32 replay buffers, right? And basically the Win32 replay buffer will have a void star pointer to the memory block, like that. And then I'm going to have this here. And maybe what we'll do too is maybe we'll say what the backing file name is. So we've got the replay file name, like that. I don't know. I don't know how necessary that's going to be, but we'll go ahead and do that. I think that should work. Okay, so we'll say that there's the replay buffer, and these are our replay buffers, and we're just going to say that we have 4 of them. Why do we have 4 of them? Because I said so. That's how many we're going to have. And so we will go ahead and move that up here. So we have the game memory block, which is our actual memory block, and then we have the replay buffers, and they have their game memory blocks inside them as well. And so what we'll do now, just to start with, is we'll just virtual alloc buffers, and instead of writing that state to disk, we'll write it just to the buffer real quickly and see how much performance benefit we get there. So basically, if we compile this, if you remember where we were at before is, let me grab my little gamepad here. We were moving the guy around, and you can see when we hit that loop, there was this big old pause, right? Real long pause while it wrote that stuff to disk. And so what we want to do is see if we could speed that up. We want to make that faster. So right here, what I'll do is I'll just loop over those buffers. Again, it's a looping day. Today is the kind of day where we loop. So we're going to say that our replay index is less than the array count of those replays. There we go. Replay index. There it is, replay buffers. So that is our Win32 state. What did I call it? Win32 state. There we go, replay buffers. And for each one of those, we are going to just go ahead and allocate a block. So this is the replay buffer. It is going to be equal to whichever one we are on, replay index, like that. And we are going to go ahead and allocate a huge amount of memory. All right, so we've got the memory block here. Excuse me. The memory block is just going to be this exact thing, right? We're just going to do the exact same allocation so that they're all the same size. We don't care what the base address of it is because we're just using it for temporary storage, right? So we don't care what the base address is whatsoever. We have the total size that we were using before, same amount. We want to do the read-write as well. So we're just going to do those virtual allocs. And then we'll go ahead and assert that we got them because in debug mode, we want to make sure that we actually can allocate all this stuff. We want to know ahead of time if our replay buffers aren't working. Looks like we can get them pretty trivially. If you are on a low memory kind of machine, that would not work. You'll get an assertion there. Again, this is something that we will to do. Maybe we'll change this to a log message so that people can run on machines with less memory when we actually have some kind of a logging system. Okay. In fact, you know what? I'm just going to go ahead and do it. I'm going to say this is going to be diagnostic, but we're not going to report it currently. We're just going to do that. All right. So we've got the replay buffer memory block thing. We want to verify that we actually got it. Actually, the diagnostic goes in here. And then all we're going to do is on that L call, right? We call begin recording input. When we call that recording input begin function, what we want to do is we're going to remove this to do because it's what we're actually doing now. We're going to go ahead and say that instead of doing this gigantic write, we're going to ignore the write for now. We're going to pretend it never happened. And instead, we're just going to seek to the place in the file that we would have been after we do the write. Because basically file handles, the way that they work, I don't know that we covered this yet, so I should probably talk about it a little bit. A file handle in Win32 stores where it last wrote to, and whenever you do a write, it sort of appends, the writes just keep going sequentially in the file. So if you open a file, you start out assuming that you're going to write or read from the very first byte in the file, and then however much you write or read, it moves the sort of the location that the next operation will occur. It moves it by whatever you did. So if you try to write 300 bytes, then the next write will happen 300 bytes into the file. You then write 500, the next one will be 800 in, right? So as you kind of do the writes, they just stack on top of each other. But you can also do seeking, right? So you can do, I think it's called set file pause. I don't know what it's called. Set file pointer, is that what it's called? I'm not sure what it's called. We're going to find out in a second. what it's called. If MSDN is slow, man. So slow. Let's take a look. I don't know if this is the right thing. I think it's set file pointer is all we really need. Let's take a look at set file pointer ex as well. See what that is. Yeah, so this is, I think, what we want. This is what we want. So set file pointer ex just moves whatever that file location I was talking is. It just sets it to somewhere. And so that's what we want. What is the minimum, what's the minimum system? XP, so that's fine. So basically what we can do with this thing is we can say, we can give it a constant. The constant says where in the file is our reference point. The current point, the end of the file, the beginning of the file. And in our case, we just want to say from the beginning of the file, we want to go a certain number of bytes in, and it's the number of bytes that we would have left if we were going to write to the file with the bytes to write thing, right? So however many we would have written. So all I want to do here is just leave space in the file. You know, I want to leave the space at the beginning of the file for that block so that later we can write it. So we're just going to call this. We're going to pass that handle. We're going to pass it the large integer. So we've got, let's see here. This is file position, right? And this is, again, those large integers with the quad part. This is how we set the 64-bit thing. So we're basically going to do that bytes written. And in fact, you know what? This will also solve our to-do about the total size. We can now actually do that total size. I think we can do that properly now if we do it the way we're about to do it. So that's going to be nice too. We kind of get rid of a limitation there, so we can have greater than 4 gigs of store if we want there. So we're going to get rid of this write. We're going to stop having this write work, and we're just going to assume that we're going to set that total size as the new position so that all of our input gets written after that big block would have occurred. So, all right, we got the file position, pass that in there. We don't actually need to know what the new position is. We'll just assume it's right, and we're going to do file begin as the location. All right, so we'll go ahead and compile that. What are you complaining about, compiler? No constructor could take the source type to oh, does it not take an address of? It just takes an actual large integer? All right, even easier. So we're going to do that, and then in lieu of the write, instead of the write, what we're actually going to do is we're going to just do a copy. We're gonna do a mem copy essentially. I don't know if we can just have Windows do that copy for us. I don't actually remember. I think we can. I believe that's totally valid. Yeah. So we can ask Windows to copy a block of memory for us from a source to a destination with some length, right? And I think that's just fine. But I don't know. Let's see. Well, yeah, I don't know if I want it to. Yeah, this is looking less like what I want. All right, well, you know what? We're gonna call it. We're just gonna call it for now. Later on, I think we should have all our own memory moving stuff, and maybe I'd rather call ours. In the Win32 layers, I usually try to call Win32 functions. I don't know why that is, but I just kind of like to use Win32 inside Win32. And it's not particularly logical. I appreciate that, but that's just the way I do it. All right, so we're going to say the state game memory block thing. That is where our game memory is, so we're going to use that as a source. We know the total size is how much we want to copy, and we know the destination is going to be that memory block for the recording that we allocated back at startup, right? So we're going to do this. Now what we have to do, of course, before we do any of this stuff, is we have to check whether this block is actually valid. So we have to check whether we ever got the recording block. So if you take a look, like I'm going to go ahead and assert this input recording index is less than that array count as well, because we might as well check our bounds here. Essentially, I just want to say, all right, let's make sure the recording index is inside the replay buffers. And assuming it is, we're going to get the replay buffer out, right? So here's our replay buffer. Our replay buffer is going to be whichever one it was asking for. And we are going to try to get this record block out of there. So I guess I could just use replay buffer arrow memory block. If the memory block couldn't be allocated, I don't want to try to write to it or we'll just crash. And that doesn't seem like a good idea, even though it is debug code. So I'm going to go ahead and say, all right, let's check to see if we actually have some memory there. And if we do, then we'll go ahead and do the copy, and that's fine. And the same thing will happen. In fact, I could go ahead and make this a utility function since we're going to call it twice right here. I could say this is get replay buffer, right? And that replay buffer thing takes the Win32 state. There's the state. and we go ahead and say that is this, right? Return result. There's the results. I can assert. Some people were nervous about the potentially that it could be underflowing. I don't know how realistic that is, but we could also do this, int unsigned index. Now we know that it can't be less than 0. Okay, so I'm going to go ahead and make that happen. Just tidy it up there. We can pretty much just assume now that this replay buffer can be had by doing Win32 get replay buffer. This pig hat is hot, ladies and gentlemen. I hope I stop being a pig soon because I am melting in here. All right, cannot convert for Win32 replay buffer to, yes, that's true. We need to take the address of it. And so there we go, because we're asking for a pointer. Index, right, pass that there. And we should be good to go. We don't need this anymore. So there's our copy memory. All right. So hopefully that'll work. And then we're just going to do the exact same thing on the other side, right? So we're going to do the exact same thing when we want to begin input playback. We're going to use the input playing index, get the replay buffer out, assuming that there is a valid memory block for it. We are going to go ahead and instead of this read file that we used to be doing, this stuff right here, we don't actually need to do that anymore. We're just going to do the copy file, the copy memory right out of the memory block. So we're just reversing what we did. So we'll copy it like that, right? Now, I don't know. I slammed a bunch of code in there, and you know that it's hard for me to talk and code at the same time. So I don't know if this is going to work, but we'll try it and see if it does. You know what? I forgot one thing before I even try it. So we have to do the same thing with the set file pointer as well, obviously, because we up here left space in the file by pretending we did the write. We basically moved the file pointer past where we would have done the write. The same is going to be true for the read file. It would have moved the pointer, and we need to duplicate that behavior because we're about to start reading there, and so we need to make sure that our reads line up with where our writes were. And I can cover that in the Q&A if that's a little confusing what happened there. We can talk about that in a little more detail. So we'll do the set file pointer here, and that's gonna be on the playback handle. We've got the file position. It's going to be that total size again. Looks like looks right to me. Everything's good there. So let's take a look. Let's see if that's something we could actually try. So do the L. That takes a phenomenally long time. Did we crash or something? I assume we crashed. No. Why did that take so long? Shouldn't that should not be even doing any disk operations. So what is going on there? That feels odd. Doesn't it feel odd? To copy 1 gig of memory at the memory bandwidth of this machine, something's up. Something is fishy. I want to tell you, ladies and gentlemen, that I feel like something is very, very fishy. I think we've got a bug that is perhaps has been in there since the very beginning. I need to think it through. But let's see here. Let's see here. What happened? I'm gonna add a couple output debug strings here, but we'll step through that and just make sure we know what's going on. Let's see here. Win32 begin recording input. So I guess the other thing we could do is not do this file thing at all as well, just in case that is creating a problem for somebody. Well, let me just double check one thing. Yeah, so like, what is it doing there, right? Is that really the cost of the copy? Because it seems odd that the copy would take that long. So this bears investigation, is what I would say. So what I'm going to do is I'm going to go ahead and comment out the copy just to see if the copy has anything to do with it, to see if the copy is really taking that long. Haha. So it has nothing to do with the copy. The copy is commented out in our code right now, and we still have that huge pause, right? So let's take a look even further and go, all right, what about the file pointer thing? 32 get input file location. There we go, recording handle. In fact, what we could do, you know what? I'm going to use a little, because we don't have a profiler yet, I'm going to go ahead and use output debug string to sort of spam things here, and use a little technique that I often like to use, which is basically just going to go ahead and spam, I'm going to spam indexes out to the debug port, right? And I'm going to spam them at each particular location so that we can see who stalls. Because I don't really know who stalls. This is not a glamorous way to do it, but you know, in short order, it's something we can do. So let's go ahead and size that down there. Get the output up. There's our output. So here we're going, and then we go L. So did you see what happened there? That was pretty interesting, I would say. It actually got to here relatively quickly. So something after begin recording input is actually causing the problem. Win32 begin recording input. So we just have a flat out regular old bug that was presumably causing problems for us even before. This is very good. I feel like this is a good thing that we looked into this, because we just have some other totally erroneous behavior happening, probably down in here somewhere. We just have something stupid going on, if that makes sense. So I want to see. I'm interested to know, yeah, what exactly is going on there, because that was an interesting stall. It stalled right after spam 4. So let's. I guess I could step through it maybe and see, because remember, it printed spam 4, right? You saw what happened. You were here. It printed this, and then it didn't print this for a long time. Now, if you could think about what that means in terms of flow control, in terms of what happened in the code, it means that we got, I can never find my way around in MSVC. We got here, right? And then when we exited, from that, you remember Win32 begin recording input is called here. So we did whatever we were going to do here. We exited out of this function of Win32 process pending messages, right? And then we actually, you know, I don't know what happened. We executing this part of the code, just executing through all this. For some reason, this time around, before we ever got to the frame output stuff, because we still output the frame, we still output this stuff, right? What did we output? BTL 33. Okay, so basically, spam 4, before this line right here, the BTL line, is all the way up here. And so something in between, in between, when we called the write up here, which is happening here, in between there and that BTL line took an enormous amount of time. So I wonder if we could figure out who that is. Let's just see if we can. What's the name of this function again? Win32 begin recording input. Yeah, this guy. Let's see if we can figure out who's responsible. Just really simply. Again, a profiler would make this very simple, but we don't have one yet. So we're going to have to do this the old-fashioned way. So here we go. We're going. We end up in here. This happens. That copy takes a little bit of time, but not that much, right? And so we come out here. We go through. Let's see what happens. So we come out. We come in here. We get these things. We process the keyboard messages. We go ahead and get our X input state. We do this a couple times. We finish all the controllers. None of them are connected. We come through here. We try to record the input. We call the write file. What? Very interesting. So it's as if the write file, so I guess it's because the write file is having to actually reserve all, when you do that set file pointer call, is actually reserving all of that space or something of that nature. Let's see if that is true. Set file pointer EX. Let's see what happens if we get rid of this, this file pointer situation here. There we go. If 0. There we go. Let's see what happens if we go ahead and do that. Yeah, so that's way faster, right? Way, 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 way faster. Very interesting, people. Very, very interesting. So basically, the act of setting the file pointer appears to be forcing the operating system to actually like go through and do all of the work on that span, which we really did not actually need it to do. So I'm not sure how to solve that problem exactly. I'm not sure how to tell it that we don't care very much about that. We could make it so that we have two separate files, one for the input stream and one for the backing store. I don't know. I do not know what we want to do about that. So what I was going to do, I'll tell you the rest of what I was going to do, is I was going to go ahead and do a memory map file, which is basically where you tell Windows that a portion of memory is just supposed to be mapping a portion of a file. I was going to do that for the memory block, and so that way Windows would just commit it to disk when we closed or crashed or whatever, and wouldn't think that it needed to write stuff all the time. Now, I don't actually know if Windows will be smart enough if I do that memory map and then we do the set file pointer thing. I don't know if it'll be smart enough to know what to do and not to do what it's doing right now, which I assume is that it's taking the time to go ahead and pad out that file. Yeah. So, very interesting. And you can see, in fact, too, loopedit.hmi is very tiny when we don't do that, and so it's very big when we don't set the file pointer because it's only recording just the input into there. Yeah. So I don't know what we should do. I don't know. Maybe we should try the memory map file thing and see what happens, just for education purposes. I don't know. Or maybe we shouldn't. Maybe this is a bad idea. I'm not sure. I really don't know. I'm torn. Here's what I will say. Let's try the stupidest thing that we can think of so far. And let's do the stupidest thing, and we'll see if the stupidest thing works. So difficult. All right. So basically, what we're going to do here is let's just try it. Let's try it. Let's do map view of file, and we'll see what happens. So I'm just going to see if map view of file will be relatively easy for us to do. We'll just try it. We'll just put it in there, and we'll see what happens. So it should be pretty easy. So basically, what this does is this tells Windows to correspond a piece of memory with a file, and every time you touch the memory, it'll write it to the file, right? So it kind of it sets up a mapping between the two. And so if I wanted to do that, I'm going to go ahead down here, and I'm going to go ahead and do that inside that loop where we do the memory mapping thing. So instead of virtual allocating this, we're actually just going to have that memory is actually just going to be a map view of file, right? And so what I'm going to do is I'm going to go ahead and change it so that what we do in here essentially is we do file star yeah, the handle. So this is the file handle. This is to the replay file. Yeah. So basically what we're going to do is we're going to say, all right, we got the replay buffer. We're going to have, it's not really a file handle, and it's not file star. I don't know why I did that. It's a handle. Again, getting kind of confused in my head. All right. So what we want to do is we got this. We want to basically set up this memory mapping. So we need to call this, I guess, memory map might be the better word for it. So we're going to have to get that memory map somehow. So we've got the file mapping object. Our desired access is going to be everything. I think we want to do read, write, and copy, right? Well, we don't want copy, so we just want all access, I believe. Yeah, yeah. So we want file map all access. That again, just doing the stupidest possible thing here. The offset in the file is just 0, 0. The number of bytes to map is whatever that total size is, right? And that's all. So we're just going to say, hey, look, I want you to map this file for us, please, and I want it to be this big. So that's all that's going to do. And what that's going to do is that's going to return us an LP void, which is the memory block. So basically, instead of virtual allocating the memory, we're asking Windows to basically set up the memory as a map to the file. So we don't need to virtual allocate anymore, because basically the memory map will do the allocation. And it's not really an allocation, it's a mapping. So it's allocating the memory, but it's also saying that it corresponds directly to the disk, and Windows understands that. The Q&A does not begin now, just in case anyone was wondering, because I want to actually see if this works. Ignore the timer. Ignore the timer. Yeah, what we want to do here is this memory map. We just got to figure out how to get that. And I assume we just need open file mapping. Let's see here. Let's see. Opens a named file mapping object. In fact, you know what? Let's see about create file mapping. Let's see. Handle the file from which to create the file mapping. The file must be open with access rights are compatible. Yes, that's fine. Will it create the file if it doesn't exist is my question. Let's see, because that is a problem for us if that doesn't work. Let's see. If the object exists for the function call, function to handle the existing object, that's fine. So yeah, you know, maybe this will just work. Let's go ahead and try it. Again, we don't have a lot of time, so we're just going to go ahead and try it. Basically, what we're telling Windows here is what the file is that we're trying to map to. So we have to pass it a file handle, of course. So we'll basically have to do a replay buffer. I guess I will still need the file handle as well. So we'll do the file handle. The security attributes, I think we don't care. So we don't care about that at all. The fprotect, we want read-write access to the pages, certainly. Would be good. We've got the maximum size, high and low. So the maximum size, high and low, we actually need to get out of the total size. So I don't actually know. Let's see there. And then we got our file name as well, our replay file name, which we haven't filled out yet. So there's the replay buffer. There's the file name. So I guess we can just call this file name. All right, so we got that. And basically the total size here, it wants us to pass the high and the low separately. So I guess what it's asking us to do is something like this, right? It's basically saying, all right, it wants the high first, right? So I'm going to shift down. This is a 64-bit value. I'm going to shift that down by 32 and pass it so that we'll get that, and then we'll pass the bottom just, you know, as is, which I assume we want to do just and it out. So basically just pull out those bottom bits. So I'm going to pull out the bottom 32 here and the top 32 here. I feel like there was ways to pull those out that Windows just had. Like I said, I usually like to call Windows' functions. I feel like there was a macro for, like, you know, there's like high word and low word, but I don't know if they exist for bigger types. There's high byte and low byte, but I don't know if there's a high long. There's a make long. No, I don't know. You'd think they would have it, right? They have stuff for extracting the other pieces. But not that one. All right, well, we'll deal with that later, I guess. The fact that maybe we'll make our own macros for it, I don't know. It just seems like they should have had that, since if they want you to pull apart 64-bit values, they should have had a thing that does that so that everyone does it uniformly and correctly, right? Who knows if we wrote this buggily? You know, you want a macro so that the user doesn't have to screw up, or can't screw up, I should say, if there's no real reason to not have that happen. So, all right. So we need to make one of these file names. I'm going to go ahead and make that happen with the HMI file. Let's see here. So we've got this guy, and we will have to start making this do something a little smarter. So what I need to do is insert the name in there. So I'll use that Windows sprintf function again that we had before to basically make one of these for each of the slots. So I'm just going to go ahead and create a string here. Using that slot index, using the Windows' formatting function that we used before, and we'll just make that so we can quickly get one for each of our files. So we'll call this Win32 get input file location, excuse me, and we will actually open the file handle directly in that code down. So instead of opening it on when we actually start recording or stop recording, we'll just open it right off the bat. Yeah, so what we want to do here is take that file name. Where is? Okay, so we have to open the file as well. So we want to do everything that's in here. we want to move all of this stuff, every last thing that was in here. We want to move all of this stuff into here, essentially. And we want these to be generic read and generic write. We want both kinds of access to it, essentially. And we will go ahead and say that the write file is gone as well. We want to keep this guy in there. We've got to get rid of that. We have our copy memory. That's all good. We have to get rid of this guy. So there we go. Copy memory. We don't want to open the playback handle. We don't want to get the file name. We don't need any of that stuff. That's just going to happen automatically now. All right. So first we have to generate the file name. One file name for every one of our replay buffers that we have. So let's go ahead and do that right off the bat here. We'll generate that with the replay index. So we'll have one for every file, one for every replay, a different file name for every replay. So we'll generate that. We will then go ahead and open the file handle. Oh, so that is true. I do need to keep doing this part. The recording handle does have to be the replay buffer's file handle, right? File handle, there we go. Like that. Playback handle and recording handle. Recording handle, there we go. So I do need to do that. So in here, I don't know if we need to open a second handle. I don't know if this thing eats the handle and we can't ever use the handle again. So I don't know if we can't use the same handle that we were using or not. So we'll have to take a look at that in a second. But for now, we'll just open one handle. So we have a replay buffer, and it has a file handle, right? We're going to open that with both read and write privileges so that we can both read and write from it. We'll create that file handle. I don't know if we need to pass a thing there that says it's OK for mapping. We'll see in a second. I'll read the documentation and find out. Then we should be able to map it. We do the map. We've then got our memory block, in theory, that will then be a backing store. And that's, in theory, all we would have to actually do. Now, I don't know if there is anything else that I'm forgetting here. Chances are good that we are. But let's see. Replay buffer file name. So wait a minute. Why am I passing the file name twice? Did I not actually have to do this create file? I feel like that doesn't make sense. I feel like I was going too fast there, and right? Because you see what I'm saying? I passed the file name in two places. Doesn't seem right, right? So either I don't have to create this handle or I don't have to pass that file name. It would seem odd if I had to do both. So let's just go back here and pay a little more attention instead of going so quickly and just see what happens. So the name of the file mapping object. This is the parameter. Oh yeah. Oh, okay. So this is not the file name. This is not what we want. Yeah. So this is just if we wanted to refer to this mapping by name. So we do need to make the file handle. That was not supposed to be the file name. That's just a wrong-headed thing. Okay. So we have the replay buffer. Get the file name. Go ahead. Get all that's going. So let's step in here and see what crazy stuff we have wrought now. Because I just did a ton of crap there. And so I think it would be good to go through and see what I did, because even I don't remember everything at this point that we just did. Okay, so first things first, we're going to get a file name. And, oh right, we can get rid of that assertion now. We were previously asserting that it was only slot index 1 because we weren't handling slot indices, but we are actually handling slot indices now, so we can get rid of that. So that's fine. Off we go. So let's step back into there. And see, there we go, and let's see what that produced. Loop edit 0, that looks good. So we get that file name. Let's see what the file name produced. Let's go ahead and can I delete these guys? Go away. There we go. Let's take a look at what that replay buffer looks like right now. Okay, so it should have the file name in there. It does. We tried to open the file handle. That succeeded. We try to open the memory map, and that did not succeed. So we have an error there. That's bad, right? That did not work at all. Why is that execute read write? I did not actually want it to be execute read write. That's wrong regardless, but yeah. So we have some bad news. You know, there's some bad things happening here. So this call is wrong, and then this call failed as well, obviously, because if we can't get the file mapping. All right, so let's go ahead and first of all, I don't understand why I've got page execute read write, because we're not supposed to be executing anything from this. So that's just wrong. I think this is what I actually wanted. We wanted page read write. Yes. So this is inside create file mapping. We've got the FL protect. what this should have been is that should have been page read write. So that's what that should have been. Okay. And then I want to know what these guys are. So this is let's make these maximum size high, maximum size low thing. And what let's read what those actually are. Let's see, remarks. The high order D word of the maximum size, low order D word of the yeah. The maximum size value is equal to the current size of the file. So no, I don't want that. So I want this to actually be, yeah, I want this to actually be what we think the size is. So these are going to be max size high, and I'm saying that that is this, right? And max size low, and I'm saying that that is this. There we go. And so max size high, max size low, and we can at least inspect those and see what they are. And let's also see what are the requirements. Are there requirements on these guys as well? If the file guide is backed by the operating system paging file, the H file parameter specifies that when a view of the files by the process, the entire range of pages committed. We don't care. I don't think we care about that stuff. All right. So what I want to know is, does this have to have any kind of does this have anything special about the file handle that we should know? Let's see. Create file mapping creates a file mapping to specified sizes backed by the system paging file. No, we don't want to do that. I wonder if we have to set the size of the underlying file to be big enough. I don't know if that's a requirement either. We'll see. So the other thing we can do here is I assume that when this fails, it will set the last error in Windows to say what the error actually is. So we could call getLastError and see what that error is. So I'm going to go ahead and put a call in there so we can take a look at it. So yeah, so I'm going to go ahead in here and say this is failing. So let's take a look at what that is. Error equals getLastError. And so let's say we go in here and we run it. And our file handle, oh, whoops, it's the memory map that fails, not the file handle. My bad. I want to see that, actually. Okay, so we come in here, we call this, and it's wrong. What's our high and low, by the way? That looks about right to me. Max size low. Let's see that in hexadecimal. For that, wait a minute. Wait a second. What is the total size here? Is that right? Okay, yeah, that's right. All right, okay. Yeah, okay, yeah. All right, I can be satisfied with that. All right, anyway, so we got the max size high, the max size low. They look about right. Let me verify that they do go in that order as well. Just want to make sure that that's the case. High and low, yes. So we've got that done, but we didn't succeed at getting our memory map. Oh. This time we did succeed at getting our memory map? What? What? What are we talking? So is it just the execute bit that was the problem? Weird. So it's the fact that it was page execute read write. I guess that's the only thing we changed. All right, so there's no error now. Let's see if map view of file succeeds. It does. So off we go, I guess. That's very odd. So now we have those files mapped, which means in theory those files should exist in the build directory, correct? And there they are. They're all the right size as well, which is good. So I don't know. That looks like it worked. Very strange. So that's good. I guess that was just because I had the execute bit. I had accidentally pasted the execute one in there, which I should not have done. But I guess that was just that was the only problem. All right. So when we're actually doing the recording here, let's go back and check to make sure we're doing this properly. So when we say we're going to be recording, we go ahead and we get that replay buffer. We take a look at the input recording index and we set that to be, what's being recorded currently. We go ahead and set the recording handle. I don't even know if this is actually necessary anymore, but probably is. Anyway, we go ahead and seek past the part that we mapped, and then that way all the writes will happen past there. And then we copy the memory into that memory map block that we used before. And the same happens in reverse down here. So I don't know, this may actually just work. I don't know if it will or not, because I don't know if you can memory map a file and write to file handles like that, but we will certainly try. So let's see what happens now. So we go down here, we hit L, we get that really long pause on that first write still happening, which is annoying. so we reset the state properly, but we're not reading back from the file properly. So I do wonder if perhaps this thing does not actually work the way that we would want it to. I'm not actually sure, but it's still getting a bit, that's still looking a bit wonky. So let's say, just for the sake of argument, that we split this into 2 streams temporarily to see what happens as a baseline in that circumstance. So let's say we pass a slot index and a bool, whether it's the input stream, right? So we do something like this. And so then there's just a loop edit, and then it's underscore string. We take a look at whether the input stream is set or not. If it is, then it's the input. Otherwise, it's the state, right? Something like that. And then we'll just actually do a separate open and a separate close for these guys entirely. So, what is this? Does not take 4 arguments. That's true. It does not take 4 arguments. So let's go ahead and do that. Input file location. So what I want to do here, right, is I want to sort of go back to the old way of doing it, but just for the input stream. And we're going to store the state in a separate file. So the input goes into one file, the state goes into another file. Just so I can see what the baseline performance is of that, and so we can figure out why writing to one file is causing us so much headaches. All right, so we've got the input stream thing coming in here. So this is not the input stream, right? It is not. And so if I compile that, I should get the thing that's not the input stream. And then when I do the begin recording input stuff, so in here, the recording handle is now not going to be that file handle. It's going to be an actual file handle. We're not going to do the seek. The seek is out. We're just going to write to a separate file. And so we're going to do it like this, right? There we go. File name and file name. There we go. Lovely, lovely, lovely. So we're just going to do this, right? We're going to go ahead and get the new file name. We're going to create that file entirely from whole cloth, just like we were doing before. So I'm going to do the create file A. I'm going to use the exact stuff that we were using here. So file name, right, like that. Generic write, and there we go. So we've got the close handle thing. Oh, you know what? This was dumb as well, because we didn't want to keep closing it. It doesn't actually matter, because that was long after our bug occurred, but that was something too. We shouldn't have ever been bothering to close the handle. That was just dumb. That would have caused us problems later. We haven't gotten far enough to have them cause us problems. All right, so anyway, we've got our create file here. Generic write, create always. That looks fine. To me, we don't need to do the seek. So we do that recording handle. We'll close it when we end the recording. When we begin playback, we'll do the opposite. The playback handle will now be this thing. And we'll go ahead and do that. So we take that out, input playing index. So now we're gonna open the file for read, and we'll do open existing to try and get the input back. And that is, again, not going to do the seek, and then the close comes back. So I think that's roughly all I really wanted to have happen. What is the complaint? Oh, yeah, file name does not need an address there. What? Why was there an address there? Oh, because that was just full on bogus. That's supposed to take the state, not the file name. Don't know what I was thinking there. Okay, so let's take a look at what we've got now. So off we go. We hit L. So that looks fine to me, right? Nothing particularly odd there. And it does seem like this is now much faster than it was, right? That pause is pretty brief compared to the old pause. I think there's no doubt that that's considerably faster, right? Yeah. So, yeah, I'm a little confused as to why the behavior is such that setting that file pointer causes that problem. But it's not like we really care, because having them in 2 files is not really a problem for us. it's totally fine for us to do that. Let's delete these guys here so that they're gone. So if we go ahead and run this, startup is instantaneous, even though we have mapped those files, because all it's doing is reserving the space on the disk for them, right? And that's fine. But now if I go back into here, when I initially do that, I do get a, it's a much shorter pause than before, but I'm still not sure if that's how long the pause should be. That still seems like perhaps it's a little long for the copy seemed to take that long, which was kind of odd. I feel like the memory bandwidth in this machine should be higher than that, but maybe that's just my intuition being incorrect. I'm not sure. But point being, we're way faster than we were before, so that's at least good progress. And then maybe we don't necessarily need to belabor the point much longer. We can think about this a little bit more, and if someday we want a bonus thing to do, we can look at it again. What I think would be interesting to do here maybe is to, I wonder if we want to actually support all 4 of the streams now by actually putting in a 1, 2, 3, 4 kind of a system. Maybe you hit Alt-1 to record that or something like this. So you do Alt-1 and then you end it or something like that. I'm not sure. Hard to say. We'll leave it like this for now, and if we ever need anything, when we need more, we'll use more. All right. Well, I think that's probably enough for now, because we did blow through a bunch of QA time, which I will just go long on the QA. I like on Fridays to kind of go long. I'm trying to think if there's anything else I want to do. I don't think there is. I just wanted to look and see how long that would take. And this is something, if people want something to play around with at home, trying to figure out exactly what is taking the time there might be interesting. Seeing if that copy memory thing happens at a reasonable speed as well. Like, should it be taking as long as it is? How long should it take to copy 1 gigabyte of memory? Because I'm not sure what the memory bandwidth is of this machine, right? Like, I'm not sure how long 1 megabyte should take to copy. And so what we need to do is actually figure that out. And I don't know, I mean, I guess we could potentially, if I go in here, I suppose we could take a look. This is a W5580, right? That's the processor type. And so if I were to go here and say W5580 memory bandwidth, would somebody tell me what it was, right? So let's see. I don't know what the memory bandwidth is. There's a lot of things that have the word memory bandwidth, but I don't know if they will actually tell me what the memory bandwidth is. Let's see. Is this megabytes per second unbuffered memory test? Is this unbuffered memory bandwidth megabytes per second higher is better? So, I mean, okay, so I don't actually know, right? I mean, I know nothing about this CPU. I don't even remember, like, I had to look up even which CPU was in this machine. But if this is actually an unbuffered memory test, right? It's saying that this is the number of megabytes per second, right? So 10,000 megabytes per second is in like the 10 gigabytes a second range, right? So 10 gigabytes a second means that it should take 1/10 of a second to copy a gigabyte of memory, right? I mean, in theory, it should really not be taking the amount of time that we're seeing. So it feels like something is still kind of wrong there. And so maybe I'm just misreading this. But you understand why I'm a little apprehensive about what we're seeing. So I don't actually know, again, what these, I'm not sure, I'm not even reading these pages because I don't have time to kind of sit here and read through them on stream, but like it's a bit odd. Let's see what this says. Here we go, here's the spec sheet, right? Here's the spec sheet for the W5580. And so here's the stuff here, QPI speed, right? Transfer of computer components are between computers. We don't actually care about that. Where's the memory bandwidth? Max memory size. Oh, wow, that's a lot of memory. 144 gigabytes. Max memory bandwidth, 32 gigabytes a second. So you see why I'm perplexed, right? You see why I don't feel like we're doing things correctly. because if the processor is supposed to be able to get a max memory bandwidth of 32 gigabytes a second, then even if we were only getting like 10% of that memory bandwidth, we should be getting 3 gigabytes a second, which means it should take 300 milliseconds to copy a gigabyte of memory. That is taking more like a second, right? And we can go time it and see exactly how long it's taking, but it ain't as fast as it should be. So there's something else, like the operating system is interceding in a way there, I think, that is making it perhaps so that, like, you know, maybe those pages that were mapped to the file, as we're doing the copy into them or something like that, I don't know, maybe it's having to sort of write them for the first time. I don't know. What happens when we do 2 records in a row? Let's ask that question, right? So there's the first record. Not taking too long, but still takes longer than I think it should. Okay, now we loop, and we're looping, right? But I can stop looping if I want to, and do another record, right? So it may actually just be the initial work of the paging, the initial time that it has to do this stuff. Maybe that's the case. Because now it's like, all right, let's do our recording, and it's like, yeah, I don't know. It's a little bit confusing to me. It's a little bit confusing to me. So, all right. Well, let's just go ahead and I'm sorry I'm obsessing on this. I know that it's just that on the Friday stream I can obsess because I don't have any hard deadline to stop me. So anyway, let's see. If this is down, if the input recording index is 0, that's gonna do it. So we need a way. We don't have a way to stop recording, right? We have no way to actually end the recording. So what we need to do is if the input recording is 0, then it starts. We need to basically say we need to do if state playback index or whatever it is. What's input playing index? If that equals 0, then we do this stuff. But otherwise, if not, we end playback. End input playback. Oops, getting too close to my head. So right, like basically what I want to do is say, okay, if there was nothing playing, then if there was nothing recording, then we begin recording. Otherwise, we end recording and begin playback. If there was something playing, we just stop whatever was playing, right? And I feel like that should do it. And I want to make sure that actually works because there's like some ping pong logic in there, right? And I want to make sure that it actually works somewhat reliably, right? So I'm here, I hit L, I do my little dance, I hit L again, we're playing back, we're looping, right? Looping, I hit L to stop, and now we're back in control. Let's see if we can do it again. Hit L, do up and down, let's say a little sawtooth, loop. Yeah. So it looks like we're good. Yeah, looks like we're good. I would call that certainly not shippable quality, but I would call that good enough for our debugging purposes for now. So yeah, let's say that that's good. And the other thing, you know what I want to do here as well is I want to do the Win32. We do that sort of drawing of the audio buffer, this sort of the sync display thing. So I want to basically get rid of that for now and say that this is not going to happen anymore. Let's see here. Win32, or you know what? Am I allowed? Let's talk about this for a second. Am I allowed to do this to prevent that warning? Can I just still leave the call in, but have it be on a call that can never actually happen? Conditional stress. No, I guess I can't. All right. Well, in that case, I guess we will just go ahead and comment out that call for now. In fact, we'll just get rid of the call entirely, and then the Win32 sync display. Win32 sync display. We are going to, because the next time we revisit that, we're going to put the drawing up in the actual platform code using a real renderer so we can draw stuff for real. So I'm just going to go ahead and comment out this stuff entirely. because we don't actually need it, and we will be moving it out into the platform layer later. So there we go. We are now at least only doing... it's so weird when the tone goes down. We're now at least only doing the rendering that we actually need to do in the game, and everything is rendering inside the game, which is what we wanted. We still have our frame rate printout, and that is something I guess we can turn off as well at the moment. We got our FPS kind of printout here. We can turn that off because I don't think we actually care about that at all. So we'll turn that off, and these will be things that, like I said, will hoist up into the actual platform code when we have, so we can have like kind of real debug displays and not these sort of hacky ones. So we're not printing out anything every frame anymore, so that's good. Kind of have that going. Do our input loop, double check that that actually works. There we go. It's in good shape. All right. I think that's it. Everything else seems relatively good. All right. So let's call that for the day. We did an extra 30 minutes today of coding because I was kind of curious about what was going on there with those memory map files. I feel like there's still more we need to learn. I feel like we need to learn really like what the most efficient way is to get Windows to kind of do the most efficient thing there. And I don't know if maybe we need to not do, I'm not trying to think if like the copy memory is doing something else that it shouldn't be doing, or what exactly is happening. And we'll have to time it. Maybe we'll do some profiling. So I would like to know more about that. I'm not satisfied with my understanding of what Windows is doing in that case, and I feel like there's stuff that we're missing. So I'm gonna go ahead and say to do Casey, recording system still seems to take too long on record start. Find out what Windows is doing and if we can speed up, defer some of that processing. So, yeah. All right. Well, that is it for now. Let us do some Q&A. I think it's time for some Q&A. So please put C Muratori. I'm gonna go ahead and, oh, I'm hot. My hair is all, I got pig hair. You know what, I can't see it. Let me see what I look like. Yeah, it kind of matted me down. I'm all matted down from the pig. You know, it looks like some kind of, skull cap hair, right? Yeah, awful. All right. Anyway, but you know, when you wear the pig hat, you got to take the consequences, right? You can't expect to have fabulous hair after you wear the pig hat. All right. So I think that's it. Let us do questions, and that'll be good. And that will be good. Please put C Muratori in your question. Let's see. Maybe first copy is causing Alec and Zero on fault. Maybe a second copy would be fast. So yeah, I mean, that's what I was assuming is basically like there's some kind of like Windows is clearing in the pages or who knows what's happening, but it doesn't really explain why the second copy wasn't more instantaneous. I mean, 300 milliseconds shouldn't be even that perceptible to us. Like it shouldn't look like a second pause. So I don't, and that was, you know, it's supposed to get 32 megabytes peak, and it was getting 10 megabytes a second in the Sandra benchmark or whatever. That means it should only be taking, 10 gigabytes a second. That means it should be taking 100 milliseconds. That should be, we should only see like a 3-frame pause, right, to do that copy. So it's just a little dicey. So I don't know. Yeah, and what we really need to do if we want to investigate this further is start timing these copy memories, see how long they're taking, and make sure it's reasonable. Let me see, what is that total size set to again? Just make sure I'm not misremembering. So it's 1 gigabyte plus 64 megabytes, right? 1 gigabyte plus 64 megabytes. Transistors. Sorry, I'm just trying to think here. So I think that's all correct. I mean, it certainly seems it. So if we come in here, let's double check. If we come in here, we do total size, Oops, total size is undefined. Win32 state, total size, right? Let's do hexadecimal display. And that does look like 1 gigabyte plus 64 megabytes. That does seem reasonable. So yeah, I mean, I don't know. I don't know why it's having such trouble. But yeah, we'd have to start doing some more serious profiling, which someday we will do when we have more profiling tools. Can you turn off the sound? Can you log on to the chat so the app will autocorrect? Turn off the sound. Do you mean just not produce the debug sine wave? But as for logging into the chat, I log in via IRC is the problem. So that's the problem with the autocorrect. Let's see. An interesting part of this project is that you're implementing all the components yourself that you'd take as given in an existing game engine. That said, do you intend for these components to be reusable in future projects, i.e. thereby almost creating a new game engine in its own right, or is all the code tightly coupled to Handmade Hero? I guess what I would say is I'm not sure, because it will depend how things come out. I am not trying to make a game engine that can be reused. So I will not be doing anything extra to make things reusable. So it is likely that a lot of things will be relatively tightly coupled to Handmade Hero. That said, it may be that in the course of making Handmade Hero, there's a number of things that just happen to be easily reusable because that's just the most sensible way to write them anyway. But yeah, I don't care about making a reusable engine. That's not part of the goal of the project. The goal is to make an engine that runs Handmade Hero so that you can see how it works, if that makes sense. Why the pig hat? Because we were being piggy. I mean, we allocated like 5 gigabytes of memory on startup, right? That's very piggy. You have to admit it's kind of piggy. Why don't you use the Visual Studio Profiler in Analyze Performance? Well, honestly, because I'd rather write it ourselves, so you can see how to have a built-in profiler. So we will be like making our own like profiling tools, so we can kind of see how they work. If that makes sense. Let's see, 300 milliseconds. Yeah, but 300 milliseconds. So I was saying 300 milliseconds because I just randomly said 10% of the memory bandwidth, so that was like a maximum. The standard benchmark looked like it said 10 gigabytes a second sustained. So, you know, if it's 10 gigabytes a second sustained, that should be 100 milliseconds or, you know, 3 frames, right? Which is just not that many. But maybe, you know, it's hard to say. Well, if we actually timed it, which is what the next step would be, we would know for sure how much long it's taking. Does it lag if you save with a smaller file size? That's a good idea because that's pretty easy to test. So suppose we take a look at these and we just say we're going to delete them, right? So we delete all our HMI files. They're gone, right? And let's say we go in here and now say that instead of allocating a gigabyte, there's just no transient storage. It's you know, another 64 megabytes of transient storage. So now we're just writing 128 megabytes, much less than we were before. It's certainly much faster, right? There's no question that it's much faster. So it's obvious. I mean, so it is definitely proportional to the size. There isn't some totally stupid bug where we're just doing something really dumb. But yeah, but what exactly whether it should be that slow though is another question. So yeah. Yeah, I'm sorry. I'm not going to turn off the debug sound because we're going to be replacing the debug sound with actual sound playback. So we just kind of have, there's going to be sound. Sound's going to happen. Isn't the CPU memory bandwidth only valid for on-die memory? No. That number, so where was that page? Okay. So basically this, I believe, well, actually, I'm not sure. Where's the cache bandwidth? I don't know what all of these are actually referring to. But basically, the memory bandwidth that they quote is for actually out to main memory. At least that's always been my experience in the past. So 32 gigabytes a second is the speed it can talk to the memory bus that actually goes to memory, right? So that's not talking about the cache, which is the thing that's on chip. There is no on-die memory, really, in terms of memory. It's just the cache, right? I mean, it is on-die memory, but we don't have stacked RAM on Intel chips, so it's not like there's 2 gigabytes of memory like sitting on the chip or something. There's only just that cache. So basically, like the cache bandwidth should be much higher than 32 gigabytes a second. 32 gigabytes a second would be pretty slow for the cache, I think. Is the intent of saving the complete game state to support something like a rewind function that Braid allows? No. You would have to do a much more efficient implementation if you want this to be a runtime feature. This is a debug feature, and it's so that we can tune things. So like if we wanted to work on, the feel of, you push the button and it shoots, and like, oh, we've got the muzzle flare and all these sorts of things, and we want to start tuning all those effects and whatever, we can just do it, whatever the action is in game, with the looping on, and then edit the code live as we go and see the results. So it's not meant to be a gameplay feature. It's strictly for our debugging purposes. It won't even be enabled in the shipping version. It's only for our debug build. Will you do a string pool? Probably not a string pool, no. We will probably do a string stack, but I doubt we'll ever do a string pool, and it won't really be a string stack. It'll be we will use stacks for our strings, but they will not be exclusively for string stacks. When you say the platform not specific layer, does that mean game code and renderer and logging sorts of things, or is there a sharper distinction between some of those? If not, could you clarify your naming and layer structure just a little? So basically, the only structure that we have is there's the platform code, which is like Win32 underscore, or later there'll be like Mac underscore or Linux underscore, and then there's all the rest of the code. So basically, the only distinction that I'm making is essentially between stuff that only runs on one platform and stuff that runs on every platform. So the idea is I want to push as much code as possible up into the stuff that runs on every platform so that you don't have to do a ton of work to implement each new platform. You want to only do the work that's necessary to do the stuff that is different on that platform, right? A quick test on my PC gave me around 3 gigabytes a second. So that's pretty bad memory bandwidth, but that might be logical for older PCs or laptops maybe. I don't know. But that seems kind of low. What kind of processor do you have? Let's see. Yeah, Uplink Coder, do you know what CPU you have? Can you look at which CPU you have if you go into like this guy and look at this? Because that would be interesting information to have. But yeah, that's not cache bandwidth. I refuse to believe that's cache bandwidth. It's so low. It just seems like that would be crazy for cache bandwidth, but I don't know. Maybe I'm wrong about that. Is it time to split the source into more files? Well, when we start programming in handmade.cpp, we will be splitting handmade.cpp into lots of files, yeah. There'll be lots of files there. Whether we'll ever split the Win32 file into multiple files, I don't know. If there's a real good reason to, maybe, but there hasn't really been any real reason to yet. Would a non-caching write be faster for the memory copy? You know, the SSE write instructions that bypass the cache. I don't see why it would be. Because the cache is not really the problem here. We are out of cache. Like, we're writing enough memory that the cache can't help us at all. So I'm, like, usually the reason that you do a write to bypass the cache, and again, I'm not really a CPU guy, so maybe there's another reason why you would do this, but my my understanding of that was the reason that you do a write that bypasses the cache is because you don't want to pollute the cache with the contents of the write. But in our case, we're reading and writing so much memory there that we're entirely out of cache in both cases. So avoiding polluting the cache would really have nothing to do with what's going on. The cache, I mean, maybe you should do it just because that way the whatever was in the cache beforehand is still in there, so you don't take a hit on the next piece of code that's going to execute. But I don't think it would change the write speed, because since the cache is very small, like, you know, I don't know, let's say 8 megabytes here it says, right? And we're writing a gigabyte, the cache just isn't involved. We're out of cache the entire time. So the only number that matters is here. Like, we're not going to get any cache effects, I don't think. But I could be wrong about that. Like I said, I'm not really a CPU guy. When are the 4 HMI files created? The HMI files are created right here in this for I loop at startup. So, you know, we come in here, we sort of do our initialization. We have our window, we get the refresh rate, we set up the sound, we allocate the memory for the game, and then we do a loop over each one of the replay buffers that we want, and we create the file right here. So here's the thing that creates the file, here's the thing that maps it into memory, or rather, here's the thing that creates the handle that allows us to map it into memory, and here's the call that actually maps it into memory. An AMD A8 6600K. So that is an AMD A8 6600K memory bandwidth. Let's take a look if we can find that out. What is this? Here we go. Frequency, bandwidth. Okay, so that's actually not, actually, well, I guess this is a little confusing. There's a lot of different codes here. To memory, up to 21 gigabytes a second, dual channel memory. Are you using it in dual channel mode would be the first question. If you weren't, it would be, you know, half that, right? Presumably. I don't actually know. So I feel like you are a third the speed of this chip. I don't know what you would be in practice, like on the benchmark here. Uplink coder. Is there a benchmark somewhere? Benchmark, discrete price performance ratio over performance, thermal design, pros and cons, model number. I don't even know if this is a legitimate site that I'm looking at here. I'm just wildly searching to see if I can get some memory bandwidth numbers. Max memory bandwidth, integrated memory controller is 29.9. Is that right? Yeah, 29.9 is the maximum memory bandwidth. So yeah, I don't know. If you're getting 3, it's a tenth of it. Yeah, I'm not sure. This is kind of a to be continued thing. We're gonna need real profiling to figure out what's going on here. I think this is not going to be a trivial thing. Are you going to do a mobile port, Android for example? Would the game loop of a mobile game be any different? So I might do a mobile port to Android. I haven't decided yet. I don't like having to deal with Android because it's all Java nasty ridiculousness. But, you know, we could use the NDK and compile mostly in C and maybe go that way. So maybe we'll do that. I'm not sure. It's possible, but not necessarily going to happen. We will definitely do the Raspberry Pi port at some point, and that basically is a mobile. That's essentially a phone. You know, it's an old phone is what the Raspberry Pi basically is. So we will be doing that. As for whether the game loop is any different on a mobile game, game loops are, it depends what you mean. Obviously the Win32 code is all different. Like the phone, whatever the phone operating system is, will have completely different platform layer. But the game itself will be written the same on all the platforms. So there won't be differences there, if that makes sense. How about disk write speed and access time? Well, in theory, we shouldn't have to pay for that. Because since it's all in memory, Windows can be as lazy as it wants writing that stuff out. So in theory, we don't care about what the disk speed is, because we're all in memory now. And basically, we did a memory map file so that Windows would lazily put it out to disk whenever it wants to, but it no longer has to do that before it can complete the operation. So in theory, it should just be memory bandwidth of copying the gigabyte. That's all that should have to happen, right? So, you know, disk write speed shouldn't have been involved. Why is the CPU even involved in a memory copy like this? So, I guess the first thing I'd say is I'm not sure what you mean by why is the CPU involved in a memory copy. What else would you imagine doing the memory copy? I guess, are you thinking of something that's like a DMA engine or something? Because really, like the memory, somebody has to move the memory from one place to another. And the CPU is the thing that does the memory ops. There's a memory controller on the CPU, and, you know, I guess I don't know if x64, I don't know if any x64 chips have a way to kick off a memory copy that doesn't involve the CPU hand holding it. You know, a Bulldozer core might have something like that because it has the... I mean, I guess what I'm saying is I don't actually know if the compiler can generate x64 instructions that would do a background memory copy kickoff that the memory controller does. I'm not sure. That's all like would be really modern stuff, and I'm not aware of it one way or the other. But traditionally speaking, at least, you know, in the old days, the memory is operated on by the CPU. So the CPU has to manually say, take this and move it here, take this and move it here, take this and move it here. So the CPU is the thing doing the copy most of the time. What was the reason for choosing get cursor pause instead of just responding to the WM mouse move message? Is the message pump not fast enough? No, it was just convenience. Since we were only going to pass it once per frame anyway, I figured why bother handling a message? Why not just ask where it is when we're about to pass it? Just easier than doing the other thing. Have I ever programmed in Java? For how long? No, I have not. I mean, I have programmed in Java, but never for long enough to... like, I've never done like a major Java project. I've only done like the barest amount of Java programming where I was like, okay, what is this? How do you do this? Et cetera, et cetera. And so if we wanted, the reason I was mentioning that is if we wanted to do an Android port, I believe, unless they've changed it recently, you still have to write a bunch of Java code at like the interface boundary to call your C code, because all of their operating system stuff all has to go through Java. And so you're talking about installing the basically a whole Java SDK environment with the Android XDK and all that stuff, and dealing with it, and you know, it's all really annoying because I don't care about Java and I don't want to program Java, but it kind of forces you to do so, right? Why is the CPU even involved in a memory copy like this? Wouldn't the copy speed mostly depend on how quickly memory from one part of the memory gets to the CPU and back? In fact, in my mind, it seems like large copies should be something that could skip the CPU entirely unless it has something to do with paging. Okay, I see the rest of the question now. Yeah, so hopefully I kind of answered that. Basically what happens is the CPU is still the thing that's in charge of the memory controller, so it's still involved in doing those copies. And I don't know if they have memory controllers now that'll do those copies asynchronously. Where it just kicks them off. It certainly could be done. I just don't know if it is done. So, I don't know. But basically, when you see that memory speed, that is sort of what that is. When you see the memory speed in the CPU, that's telling you how fast the CPU can issue instructions to the memory controller, right? Like how long, how fast can the memory controller respond to when the CPU says, give me a piece of memory. And what's important to recognize is it's only the only reason you would want that asynchronous copy is just so the CPU can go do something else. But you're not making it any faster by taking the CPU out of the equation, because the CPU's clock speed is way faster than the memory can be handed to it, right? The memory bandwidth that the memory controller can hand back to the processor is way less than the processor could handle. So we're not getting slowed down by the fact that the CPU is involved at all. The only thing that you would say about it is the CPU can't go do something else while it's happening. But definitely the CPU could chew through the memory way faster than the memory controller is handing it back. So the fact that the CPU involved is not making us slower. So that is probably why they don't care so much about asynchronous copies, because the CPU is so much faster that, like, you know, just launch it on a core and let it go or whatever, and it'll just basically be sitting in some hyperthread or something. But I don't know. So, is it worth writing games in Java? Well, I don't want to write games in Java, but that's my personal preference. If you want to write games in Java, then you should write games in Java. I mean, I don't know whether I'd say it's worth it or not. I mean, I do know that there are very few games that shipped that are successful that are written in Java. But that is, you know, I mean, Minecraft would be an example of a game that was successful that was written in Java. So it can be done. And then the other thing is, you know, a lot of the reason that high performance, high profile games are written in C and C++ is because that's what high performance programmers program in. You know, could they go do a high performance game in Java? I don't know, probably not. But maybe they could. You know, if all the high performance programmers decided to go spend their time trying to figure out how to make Java run fast, maybe they could. I don't know. So I don't really have much of an opinion about Java other than I don't like it and I don't see the point of it. So I haven't bothered to learn it and program in it. But if someone else wants to do that, then that's totally their prerogative. My main problems with it are basically that, like, I don't see the purpose. Like, it doesn't seem to give me anything that C doesn't give me. I think it has slightly better introspection support, but I can get around that pretty easily in my own code. So mostly Java just doesn't have what I want, which is like pointers and things like this that are better at expressing memory, direct memory access. It forces me to use garbage collection, which I don't want to do because garbage collection just wastes CPU time for no real benefit. So I don't like that aspect of it. It runs on a VM, which means I don't actually get to see what the code is and can't necessarily manhandle the assembly, a lot of that stuff. So I don't like any of that. So I just don't see what the point would be of me. It just seems like a bunch of stuff I just have to fight. And basically, if you use some kind of stuff in Java that allows you to kind of get past those things, then you're basically back to C anyway. So I feel like I should have just been programming in C, right? I mean, another way to say that more concisely would be all the stuff that Java adds to C is stuff I don't want, and it gets in my way. So that's why I've never bothered going the Java route. But if you're somebody who wants garbage collection, you know, who wants a VM, who wants those things for some reason, you have like legitimate reasons for wanting those things, then maybe it's a good language for you to program a game in. I don't know. Are you in dual channel write mode on your system? I believe so. I mean, I'm not actually sure, but I believe this system was set up with dual channel, but I'm not sure. Does the megabyte have any effect on the performance of the memory? Oh, you mean like how much megabytes there are? I'm not sure. Again, these are things that are like modern memory systems I'm not an expert on, so I'm not really prepared to say at all. I do not know. Yeah, so Tom Forsyth is saying that CPUs do have DMA units, but they're not easily available for user programs. It's all I/O stuff. Yeah, that's what I would assume. Like, for example, I would totally assume that, like, especially like AMD chips that have the, well, and Intel chips now have the graphics stuff integrated into the CPU, right? And so you're gonna probably have async copy stuff happening. I mean, so you have to have support for async copy stuff in there. I just don't think the CPU ever accesses it really in that way. I don't know. So I, you know, it's probably stuff that only the kernel is doing or only the chip is doing based on graphics things, or I don't know. But yeah, so I don't have much experience with that. But Tom is saying that is more or less confirming what I was saying, which is that you don't really get to use async copies in your code. What do I think of TDD? Test-driven development, I assume? I think it's not particularly useful for games because games tend to be very hard to write in ways that can be test-driven. But sometimes it's useful for subsystems. Like if you have a system whose configuration space is very small, then you can use test-driven development, okay. But games, the things that are hard to debug in games tend to be things that cannot be written with tests. Like there's no way to write them to be tested. So so TDD just doesn't really work. The reason TDD is popular in other industries is because their programs are much simpler than games are. They have very well-defined inputs and outputs, so TDD works in those circumstances much better, right? Can you explain the bit shifting? Yes, I can. So the bit shifting we did was really simple. It's just in terms of it's the high-low thing. So basically what happened is I had a 64-bit value, but because of the way Windows set up their API, they don't accept a 64-bit value. They accept two 32-bit values, which then they will reassemble into one 64-bit value. So in order to take this 64-bit value, which is the total size, and produce two 32-bit values, the high part and the low part, I first needed to get the high part out. So I shifted down by 32, right? Which basically moves the high 32 bits into the low 32 bits and clears the high 32 bits. I then just go ahead and assign that to a 32-bit value, which is, basically, this is a cast here, right? This is doing this, right? So I'm now truncating that out. I'm lopping off the top. I then do the opposite to get the low 32 bits out. I mask, right, the low 32 bits, which will clear the high 32 bits, and then again do the cast. So this is just basically, I'm just extracting these two things. The drawing of this, by the way, I tried to get Krita working. I don't know if it will, but I tried to get it working. Let's take a look here. Let's take a look. So if I oops, let's see here. If I hit create here, I don't know if this is going to work at all. It was a little, Krita's a little crashy, I will say. At least on Windows it is. So it was a bit problematic, but let's take a look. So here we go. Okay. So what we're looking at here is we've got a 64-bit thing, right? So this entire thing here is 64 bits, right? And so that means we've got a high 32 bits, right? And a low 32 bits, right? Hopefully this makes sense. So this is our value here. This is total size, right? It's 64 bits long. And we got some bits up here and we got some bits down here. And what we want to do is we want to extract this into two separate pieces, right? We want to basically be able to do this operation into two pieces, the high piece and the low piece, right? So what I did is I said, all right, the first thing, we can think of it in two ways. In order to get the low 32 bits, in order to get this part out, really all we have to do is cast it to a 32-bit value, which I did with that parentheses D word, right? Which will convert the value to only being 32 bits long. But in order to make sure that it didn't do something like take a look, I wanted to make sure the compiler knew that I wasn't trying to convert the value to the closest 32-bit number, in which case it would, if there was any bit set up here, it would be just like all the bits set down here. I want to just extract just that part. So what I did with that and, remember FFFFFFFF there is just all ones in the low bits, right? It's 32 ones up here. So what I did with that and is I basically had all zeros up here, right? And all ones down here. I do the and, which again, nothing up here, doesn't matter what's set up here, since all of these are zero, since all these inputs to the and are zero, it'll knock out everything that's in here. So it'll be all zeros up here after we're done. And then since these are all ones, anything left in here will still be there. So the and basically just, takes just this part and puts it into a separate value for us, right? So that's what this line does, right? It does an and to knock out, it keeps this part of it, the low 32 bits, and knocks out the top part, converts to a 32-bit value, and that's our low. For the high, what I did is I said, well, I want all of these, right? I want this side of things. But if I just go ahead and cast it to a 32-bit value, it's going to keep this bottom part and throw out the top part. So I want the opposite of that. So what I did is I shifted this down by 32 to move these 32 bits into these 32 bits. Shifting down shifts zeros into here. So I've already got all zeros at the top. And the 32 bits that were on the top go into the bottom. Once that happens, those 32 bits from the bottom, I just do the cast, and now I write them into here, right? And that's what this line does. It just shifts down by 32 and converts to a 32-bit value. So that extracts the high, extracts the low, and then I've got the high and low and I'm done. So hopefully that makes some sense. So somebody says, you can create a performance-heavy application in Java without the garbage collection if you configure it to run as real-time instead of virtually. I'm not sure exactly what you mean as real-time instead of virtually. But again, like, I'm just trying to underscore the fact that I don't want to have to fight a garbage collector and a VM to make my application fast. In C, if I write it, it just already is fast. So all I'm doing with Java is adding headaches for myself, where I have to fight the language to make the code do what I already could have just written it to do in C. And so that is the real problem with high-level languages these days. And it's frustrating because I feel like people don't seem to acknowledge this fact, which is that I don't ever want to fight the language for performance. Performance should be a given. I should be able to write code that tells the CPU exactly what to do. And if the high-level language can't do that, then it's just not interesting. I don't think that's a useful thing. We should have high-level languages, but what they should be is they should be built on that concept and then layered on top of that core ability to write exactly what the CPU should do, should be facilities for more easily expressing those things that you would construct so that they can lever on top of one another. And I've yet to see the high-level language that does that. They all don't do that. They all are misguided in some way or another that makes it so that they fall short of that goal, in my opinion, which is unfortunate. But someday I think we'll have one, and then that will be a really awesome high-level language, because then you will have the benefits of high-level programming without the drawbacks that all of today's modern high-level languages have, which is that you have to fight them to get your performance back. Do I consider Visual Basic a programming language? Yeah. I mean, I think I've only used Visual Basic once, and it was many, 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 many years ago. I think I was writing some like Word automation stuff in it or something. But anything that allows you to program a computer is a programming language, and Visual Basic certainly allows you to program a computer. So yes, I would definitely consider it a programming language. I don't know what else I would consider it if I didn't consider it a programming language. Connor Rents. C++ or C#? Is that a question? I'm not sure if that's a question. On the memory CPU speed, I see the answer is that the hardware doesn't do this. I guess I'm just envisioning a system where the gigabyte of memory never visits the CPU. I am envisioning that the memory could receive an instruction that says locally move the gigabyte over to this location. So yes, Mr. Fourth Dimension, that is what's called a DMA engine, usually. And they exist on many things, including modern CPUs, just I think, just not in ways that you can really use in the way that you're thinking of. On things like a PlayStation, right? Like on the PlayStation 2 or something, you do a lot of exactly what you just said. There's like DMA engines that you program to move memory around and stuff. And they are kind of like their own little processors that all they do is move memory around. And so that is a thing. It's just not a thing that's common on x64 chips because the instruction set just didn't grow up around that. So you just, yeah, you don't really have that thing available to program in the ISA. Like, it's just not there. But I feel like, I could be wrong about this, but I feel like on like a Bulldozer core or one of these cores that's like an AMD core, I feel like there's probably ways to kick off DMA and stuff on those nowadays. Maybe in Mantle, I don't know. Like I said, I haven't done any of that stuff. I don't know if you can or not, but I would be surprised if there wasn't some of that going on like the modern integrated graphics CPUs at least. That's a good point. Tom Forsyth was pointing out that one thing we could do if we wanted to not do this bit shifting here is we could use large integer. Right, that thing that Windows uses. We could do something like, okay, large integer max size for the file mapping. we just say, okay, the max size, we have that quad part that we've been using, right? We could do that, but then instead of doing, we can just use that to extract the two values that we wanted, right? So basically it's a union, right? If you remember unions, when we talked about those in C, basically we can say that, here we go, this is the union, right? And you can see the union has a struct that has a low and a high, right? And it also has a this quad part. So if we assign to the quad part, which is 64 bits, we can then read out of the low and the high part, and those will actually give us back the 32 bits that are at the top and the 32 bits that are at the bottom, right? So we can actually just have the compiler do it for us if we want to, and it'll generate the code if we just do it this way, right? And then you don't need to worry about doing that operation yourself. Does that make sense? So, you know, now we've done basically exactly the same thing. Right? And so that's, yeah, so Tom Forrest was just pointing out the fact that I was saying there was no macro, and there isn't a macro, but he was saying, oh, you could use large integer, which you can. So you can just use that as a way to kind of convert values, assign them to the quad part, pull them out of the high-low, or you could do the opposite. You could assign to the high and the low and then pull out the quad part if you were trying to assemble a 64-bit value. So kind of useful. In your mind, what would be a good way to demonstrate to a potential employer proficiency in the type of engine programming you are teaching? I know this is a long way off and I'm still just learning, but to prepare for the future, what would you recommend? To be honest, I have no idea. I am not involved in the kind of hiring that happens at like lower levels of game development where you're talking about like an entry-level position or something, like an entry-level engine programming position. So I don't know how those decisions get made, and I don't know how people come to the attention of the hiring people. So I'm afraid I can't really answer that question. All I can really tell you is that at the end of Handmade Hero, if you actually understand everything we did in Handmade Hero, if you really do understand it and could do it yourself afterwards, then you would be immediately able to contribute to an engine team, I think. But how that translates into getting hired, I don't know, right? All I can guarantee you is that I'm teaching you the stuff that the mental processes, the code structure, the architecture understanding, the way to debug things, the way to profile things, that's good enough to be on an engine team. That we can guarantee. Now, how to get hired on an engine team, I don't know. So that's like something for an HR person, perhaps, to answer. But I'm not too familiar with that. Chasing Tiger, thank you for the thank you. He was just saying thank you for the stream. I am delighted that you like it. It's really awesome to come and see people on the stream, to be honest. It's just been awesome how many people have come to watch Handmade Hero, because I didn't think that many people would, at least not till the game was up and running. And I could say, hey, look, there's like a cool game. You should come watch how it's being built. And people are like interested right from the beginning, which is kind of awesome. And it's made it so it's not lonely. You know, I'm not sitting here on the stream going, hello, 0 viewers. Let's talk about whatever today. It's like, it's just pretty exciting to know that I'm talking to a large number of people who are actually interested in what we're doing. So it's been pretty awesome. Let's see here. What defines the boundary between a high-level language and a low-level language? That's kind of a good question, and I think it's a little nebulous, right? Like, it's kind of something that probably doesn't have a very specific definition. It's kind of more about your sense of it. The way I think about it is I would draw the boundary. I would probably draw the boundary at whether or not it has features designed to whether or not it has a significant number of features that are simply designed to create code as opposed to, that are designed to create code structures as opposed to things that are designed to tell the processor what to do. So like a low-level language is one that has features for generating assembly code, like directly generating assembly language. So C is pretty good at that. It basically just has a bunch of features that pretty much all they do is generate equivalent instructions on the CPU, right? And I would say a high-level language is one that has a set of features that are designed to create whole structures of code that each themselves have how they would generate assembly language. So it's like coming up one level from that specificity. So in a high-level language, I think of as having that layer where it's like, you know, an example would be, let's say that I write a bunch of low-level code that is all the code necessary to make a stack of objects, you know, like a memory stack. And I think of a high-level language as something that allows me to generalize the concept of a stack so that anytime I want a stack, I can make one using this code that I've written and have a bunch of control over which features the stack has, how big the things on the stack are, how often it allocates it, all that sort of stuff. So I'm kind of like meta-programming at that, so I'm pulling back a level and allowing myself to generate code using parameters as to how the code should be generated. And different languages succeed or fail at this, you know, in various ways. So whether something is a good high-level language is different from whether it is a high-level language. Certainly C++ is a high-level language. It's just a really bad one, right? But it is trying to be one. It's just awful at what it does. And some other languages, you know, probably something like Python is a very good high-level language at certain things, but in terms of actually creating determining what the CPU does, it's awful. So at some level, it's a bad high-level language at one goal, a goal that I find important, which is giving the high-level programmer control over exactly what ends up happening on the CPU when they care. So, you know, like I said, I've never seen a good high-level language so far. I'm still waiting. When will I start actual game logic? Probably Monday. Well, maybe Tuesday, Thursday, Wednesday. I don't know. Sometime next week, we'll start game logic. Have I heard of the Rust language? Yes, but I have not actually played with it much. I only cursorily looked at it. Based on sort of the attitude of it, it didn't look like something I would be interested in, but you know, it's hard to say without having actually written some programs in it. Obviously, the language I'm most excited about is John's. So the language I hold out the most hope for is the one that John Blow is working on, because he seems to be one of the first people designing a high-level language who has like a proper approach to it, I think. Have you ever dealt with programmer burnout, or how do you deal with the fact that often there are days almost no code gets written, and on some days massive amounts of code gets written? So I guess what I would say is I rarely have any problem with programmer burnout if I'm just writing code that's supposed to do something. So I've never had that happen per se. What I do have a problem with is when I'm trying to develop a new technique and I just don't know how to do it, right? Like when I'm working on something that either I don't know if it's even possible, which can happen sometimes, like you're like, I don't know if what I'm trying to do is possible. Or if I'm working on something where I'm like, I'm not sure how this architecture should work, and there's a lot of different ways it could work, and I have to kind of think them through. Those sorts of things, you can definitely get into that situation where like nothing is getting done. Typically what I try to do in those circumstances is be self-aware enough to recognize the fact that nothing's getting done. So recognize the fact that you didn't do any work today. Be like, okay, we're in a bad situation. And then what I would do is I'd take that opportunity to go, all right, I'm going to write at least an hour's worth of code tomorrow on whatever first comes to mind, right? So let's say I'm having a lot of trouble with this architecture and I just can't figure out the right way to do it. Then what I tried to, and like no code got done today, like nothing got done. It was like 8 hours of sitting in front of a computer and doing nothing. Then the next day what I'll try to do is just like, all right, I'm going to take the first thing I think of for this architecture, even if it's absolutely the stupidest idea. Like whatever my last thought was, that was what I got to when I was trying to figure this out. No matter how dumb it was, I'm going to just implement it. Because a lot of times what you find is just getting the code out there and then having something to work with is enough to kind of break through that barrier. And so typically what I find is the way that you get into those stuck situations, the kind that you're talking about, those stuck situations often are because you're not coding. You're trying to think something through and you're trying to think it through too far. And you've reached the limits of what your mind can comprehend without seeing it and without playing with it. So what you need to do is get it out there. And so I usually find that that's the way to do it. And if you can just make sure, just force yourself to write an hour of code a day in those situations, eventually you'll break through and you can get back up to writing a reasonable amount of code. The only thing you must not let happen is stopping writing code entirely. When you do that, you run the risk of getting into that circumstance where you have several days and you don't get anything done. So that's what I would say about that. Any source or book recommendation for understanding the concepts you use better? Not really, because I don't think there's been a lot of books that are... Like, I find that most programming educational materials, when I look at them, I'm kind of horrified at the things they're teaching. I'm like, that is not the way to be an effective programmer, right? And so I have a hard time recommending anything because I'm like, I don't know. I'm not sure. There might be some books out there that are good, but I don't know what they are. Certainly the books I read when I was learning to program are not good. Yeah. So I don't know. I'm sorry. I don't have a really good recommendation. Have you seen Game Programming Patterns by Robert Nystrom? I don't think so. Although I think someone has sent me that recently. I haven't read it yet, but I think someone was talking about it. Are you going to use any design patterns? So the phrase design patterns is a little confusing to me because people use it differently to mean different things. I guess what I would say is I have my own set of ways that I do architecture, and you could call those design patterns. They're like whatever you want to call Casey's design patterns, and they're like, these are the ways I tend to structure things. And in that sense, then yes, I would. Like you would see these sorts of things used in various places of my code, and they're similar, right? In terms of design patterns, like the design patterns that are maybe in the book Design Patterns, I find that those are very odd things to call design patterns because they're more like utility classes or something. They're really strange. Like, I don't really understand what people mean when they say design patterns because I feel like different people use it to mean different things. So it's hard for me to answer that question, if that makes sense. Do you find it useful to learn many different languages to gain perspective? No, I don't. I think programming works from first principles very well. So I think what's valuable to learn is how CPUs and hardware work. That's what I think. Because anything you will ever do with a language is just generating stuff for the CPU to do. And so the most important thing is that you understand how the CPU and the system works. If you understand that, then everything that is efficient about programming can be built on top of that. And in fact, when you think it through from first principles in that sense, that is the easiest way to recognize and realize what's so bad about modern high-level languages. Because you can see as you go up each level, you go, okay, here's how the CPU works, here's how I'd program it in assembly language. Here's how I program it in C. Okay, that's okay, but I lost some stuff. And you can sort of see what the problems are in C just by looking at what you can do in assembly versus what you can do in C. C loses a bunch of things, and you're like, that's a bummer. So a better C language would fix that. And then going from C to something else, like a Python, a Ruby, or C++, or whatever your higher level language of choice is, you can see how they basically just don't get it. Like the people who design those languages don't understand what you actually needed to make your job of programming in C easier. because, or rather programming an assembly language, you might even say easier, because they don't allow you to loft the commonalities up, which is what you're trying to do. You're trying to make something that will allow you to say, here's the assembly language that I wanted to generate. I want to specify that once, and now I want to loft that up into something that I can easily specify in a variety of ways such that it meshes properly and does, things properly and whatever. It's so obvious when you look at it what you really should be doing to get to that high level language. And I don't know why universally almost all high level languages don't even seem to try to do the right thing. I don't know. I think it may be because the types of people who do language design maybe aren't the types of people who write efficient programs. It might be because languages are hard to write, and so you spend a lot of time focusing on other things and don't realize that you should be focusing on this. I don't know. But I find that whole high-level language mess to be rather frustrating because I find like they're mostly not very intelligently done. That's what I would say. What do you think about using VCS for one-man projects? I always do use version control for projects, even my own projects. I have one that I wrote myself, and that's what I use. I wrote it to do the things that I want to do conveniently. And so I would recommend using a source code control system. I don't super like the ones that exist currently, which is why I wrote my own. But I feel like most people can usually find one, existing one, that's suitable enough for them and use it. So if you can find one that's okay for you and that you're comfortable with, then you should use it, I think. What's your mindset when looking at a problem that's new? How do you approach a new coding problem that you have no predefined idea on how to solve? So we will be seeing that in the stream. So like I've intentionally set up a bunch of stuff like in the game design that I've never done before in a game logic or anything. And so I will be sort of showing you how I work through it. I'll make all the mistakes, I'll rectify them, I'll revise the architecture, I'll do all those things so you can watch me do them. So that will be very well elucidated as we go through the stream. Will I write a book after Handmade Hero is done? No, I don't think so. I think Handmade Hero will be probably what I can contribute in terms of education. So, how long have I been in the industry? 2 decades in the industry. So Tiny Construct has a question for me and Tom Forsyth. I've always been a hobbyist. The more I've learned over the last year, the more I love programming. In your opinion, is going back for a 4-year CS degree a waste if I want to learn to make things that don't suck? That's a tough question. I'm going to let Tom answer that one because he actually went to university and I did not. So I'm not really in a position to say. Perhaps the problem with high-level languages is that they are less general but more domain-specific in the first place. It could be. I think it's just that they don't care about the right things. I think they get caught up in trying to be clever within their own framework, and they don't understand that the point of programming is to make a CPU do things. And so what you're trying to do is have the most concise way of expressing exactly what the CPU should be doing. It is not to have the most concise way of expressing what the language is doing. And those are two very different things, and I feel like high-level language designers just have never understood this somehow, which is weird. But that just seems to be the case. How does your source code control differ from something like Git or SVN? Well, basically it's designed just to be used by me, so it's basically it's one command. You type cmirror. That's it. So whenever you're done working for the day, you just type cmirror in, and that's it. There's no push, pull, update, get, grab, frob, diff, whatever. It's nothing. It's just like cmirror. That's it. And then you just have a directory on the server that's got all the versions. So if you ever want anything, you can just go browse them and grab the one you want. So it's just designed to be as simple as possible and stop getting in your way. I find that like Git and SVN make me do a bunch of stuff that I don't want to do. Like I don't ever want to think about the source code control. As far as I'm concerned, the source code control is just a safety net. It should only be there to catch when I've accidentally like deleted a file or accidentally modified a file that I didn't want to. It's only supposed to be able to get that back for me. and anything else it does slows me down, and I don't want it. So yeah, it's one command. That's all. C mirror, and I vastly prefer that. Okay, looks like we've come to the end of the questions. It is 1:30. This has been a very long stream today. Thank you very much for joining me for Handmade Hero. If you enjoyed the program, we do have a Patreon that you can support by clicking. You can go to handmadehero.org and click on the Patreon if you would like to essentially subscribe to the series. Also, if you want the source code, you can always pre-order the game on handmadehero.org, and you will get a link to download a zip file that has every day's source in it, so you can grab any day that you want and follow along at home. If you would like to discuss the show, news and forums is the button for you. You can go on there, and there's a great site that has all kinds of stuff, an episode guide with links and stuff, time-coded and everything. Coding resources, which has ports to Mac OS X and Linux on it, if you want to use a different platform than Windows. And then also code discussion where you can ask questions and all sorts of stuff. So that is it for today. We will be back on Monday at 8 p.m. Pacific Standard Time. I certainly hope to see everyone there. And thank you very much for joining us. I hope to see you on Monday. Take it easy, everyone.